When we talk about traveling through space, there's always going to be one gigantic and unavoidable problem that needs to be overcome. It's having enough energy, basically the right kind of fuel, to reach your destination. Every sci-fi story introduces some imagined plot device to sidestep the energy problem, like warp cores, hyperdrives, and so on. But that's why we call it science fiction. None of these technologies exist in the real world today, and while breakthroughs could change the game, they aren't on the horizon in our lifetime. But that doesn't necessarily mean that we'll never see a spacecraft travel between the stars of our galaxy. It just means that we need to find a new approach to powering those spacecraft. And the best place to start looking is actually going deep into our own history. For most of human existence, we traveled by boat, using wooden oars powered by human labor or cloth sails driven by the wind. Sailing ships carried no fuel, yet they crossed vast distances by harnessing the forces of nature. Even today, sailboats glide across lakes and oceans, moving without engines, guided solely by the movement of air. Now, what if we could apply that same principle in space? Before we do, let's take a closer look at how sailing actually works, because the forces that drive boats through water might reveal something surprising about propulsion beyond Earth. Ask yourself this question: what moves a sailboat? The answer seems obvious, right? It's the wind. But where does wind actually come from? You see, wind is driven by differences in temperature. Some parts of the Earth heat up, while others remain in shadow. Hot air expands and rises while cold, dense air moves in to fill the void. This movement is what creates the wind. And at the heart of this entire process is the sun, the engine of all weather and nature on Earth. So, in a very real way, sailboats are actually solar-powered. For thousands of years, sails let people cross the great oceans, but even the greatest sea voyages pale in comparison to the boundless empty space beyond our planet. The ocean is vast, but space is infinite, a pure vacuum where nothing pushes, pulls, or drifts without purpose. So, how do we move through it efficiently? Our current rockets are simply too slow and too inefficient to reach the stars above us. Apollo, the space shuttle, and today's SpaceX missions rely on chemical fuel, burning through massive amounts of propellant just to break free of Earth's gravity. Even reaching our closest neighboring planets remains incredibly difficult with chemical rockets. Scientists have explored new ways to make space travel faster, like nuclear propulsion, ion drives, and even antimatter engines. Each offers promise, but each comes with massive challenges. They need too much fuel, they aren't efficient enough, or the science just isn't ready to take us to another star. Proxima Centauri, the closest star system, is only 4 light-years away, but with today's rockets, that distance might as well be infinite. So if traditional rocket engines won't get us there, then what will? Among modern propulsion systems, ion drives are the most fuel efficient. They use electricity to generate thrust, allowing spacecraft to accelerate steadily over time. With enough fuel, an ion-powered vessel could eventually reach incredible speeds, far beyond what chemical rockets produce. But there's a problem. Xenon, the dense gas required to create the ions in the first place, is limited. We simply can't carry enough of it to achieve the necessary acceleration for the immense distance between stars. The Parker Solar Probe holds the overall speed record as the fastest spacecraft ever launched, accelerating towards the sun at over 690,000 kilometers per hour. But for spacecraft traveling outward into deep space, Voyager 1 remains the fastest moving away from the sun at about 61,000 kilometers per hour. At that speed, reaching Proxima Centauri would take more than 17,000 years. So a probe sent today wouldn't return meaningful data for another 350 centuries. If rockets can't take us to the stars, then what will? The answer isn't more fuel or bigger engines, it's something entirely different, something that doesn't require fuel at all, like sailboats powered by the sun. Could we do the same with a spacecraft? Well, actually, we already have. The technology is called a solar sail, driven not by engines, but the gentle pressure of light, the same way a kite is pushed by the wind.